Hello children, welcome to the grade 8 mathematics classroom. Today we are going to start our third term lessons. So you need to have your mathematics part 2 textbook and a notebook. What is the first lesson in the third term? Yes, lesson number 22, volume and capacity, page number 77. These are the objectives of the lesson. By studying this lesson, you will be able to obtain formulae for the volume of a cube and a cuboid, find the volume of a cube and a cuboid by using the formulae, identify what volume and capacity are. Finally, you will be able to estimate capacities. Okay, children, before start the lesson, let's do a small activity. This is a glass filled with colored water and these are cubes. I am going to put these cubes into this glass. You have to observe it carefully and you have to tell me your observations. What happened to the glass? Yes, water overflow. Why is that? Yes, because these cubes need space inside the glass. Now I have a question. Tell me what is the amount of space occupied by these cubes inside the glass? Yes, it is equals to the amount of water displaced. Now I have another question. Tell me what is the amount of water displaced? If you can collect the displaced water to a measuring beaker, then you can measure it. Now, it is clear that children, these cubes occupy a certain amount of space. We call this space as volume. I want to build up a definition for the volume. Let's build up a definition for volume. Observe this one. Read it with me. Okay, let's read with me. The amount of space occupied by an object is called its volume. Look around your environment. There are cupboards, chairs, tables, books, lot of things in your environment. These objects have a certain amount of volume. We can measure this volume also. But in this lesson, we mainly focus our attention to volume of a cube and a cuboid. Okay, let's move to our first part, volume of a cuboid. We have to find out a simple method to find the volume of a cuboid. Look at this. This is a cube. I am going to build up a cuboid by using these cube. The side length of this cube is 1 centimeter. So, we call this type of cubes as cubic units. In my cuboid, there are 3 layers and each layer has 8 cubic units. Okay, children, let's develop the cuboid. This is the first layer. Let's count the cubes. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 cubic units in the first layer. This is the second layer. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 cubic units in the second layer also. This is the third layer. 2, 3, 4, 5, 6, 7, 8. There are 8 cubic units in the third layer also. Now tell me how many cubic units are there? Yes, there are 24 cubic units. It means the amount of space occupied by this cuboid is 24 cubic units. Or in the other way, we can express this one as The volume of this cuboid is 24 cubic units. Now, let's represent this cuboid like this way. The height of the cuboid is 3 units. Lengthwisely we saw that there are 4 units and breadthwisely we saw that there are 2 units. Wait a minute, if you multiply 2 by 4, you can get the answer as 8. 8 means the number of cubic units in a layer. If you multiply this 8 by 3, what is the answer? Yes, 24 cubic units. It means the volume of the cuboid is 24 cubic units. So, without counting, we got the answer. 2 times 4 times 3 is equals to 24. What are these 2, 4 and 3? Yes, 2 means breadth of this cuboid and 4 is length of this cuboid. 3 is height of the cuboid. So, it is clear that children, if you multiply the length, breadth and height of that cuboid, you can get the volume of this cuboid. Let's build up the relationship. Volume of a cuboid equals to length times breadth times height. This is the relationship for volume of a cuboid. Now, you have to do a small activity at home. Look around your environment. There are many cuboids. It may be a brick or a box or a lunch box. It doesn't matter. You have to get that cuboid and you have to measure the length, breadth and height. Then you can find the volume of that cuboid. Wait a minute. What is the measuring unit of volume? Yes, we have to discuss about that. Let's move to measuring units. If you have the measurements in centimeters, remember that measuring unit of volume is cubic centimeters. If you have the measuring units in meters, the measuring unit of volume is cubic meters. Remember that all the 3 measurements should be in same unit. Okay children, let's discuss few questions. Read this question with me. This question is in your review exercise, page number 78. Find the volume of a cuboid with length, breadth and height equal to 10 centimeters, 8 centimeters and 4 centimeters respectively. Children, first of all, you have to represent this data in a diagram. The length is 10 centimeters, breadth is 8 centimeters and height is 4 centimeters. Tell me, what is the measuring unit of volume? Yes, all the 3 measurements are in centimeters. So, the measuring unit of volume is cubic centimeters. Okay, you have to write the relationship as volume equals to length times breadth times height. Let's substitute the values. Length is 10 centimeters, breadth is 8 centimeters and height is 4 centimeters. 10 times 8, 80. 80 times 4 is 320 cubic centimeters. Okay, let's move to the next question. The length of a tank is 2 meters. Its breadth is 1 meter and its height is 2 meters. Find the volume of this tank. You already know that you have to represent the data in a diagram. This is the diagram. You can represent the measurements and now you have to write the relationship. Volume equals to length times breadth times height. Okay, let's substitute the values. Length is 2 meters and breadth is 1 meter, height is 2 meters. Tell me, what is the measuring unit of volume? Yes, all the three measurements are in meters. So, the measuring unit of volume is cubic meters. 2 times 1 is 2. 2 times 2 is 4 cubic meters. So, the volume of this tank is 4 cubic meters. Now, we talk about the relationship of volume of a cuboid. Now, we are going to build up a formula for volume of a cuboid. What is formula? Yes, a mathematical relationship expressed in symbols. We have a relationship. What is the relationship? Volume equals to length times breadth times height. Now, you have to express this relationship by using symbols. What are symbols? You already know that in mathematics, we use algebraic terms as symbols. Do you know any formulae? Yes, we learned few formulae in grade 7. P equals 3L, P equals 2 times L plus B, P equals 4x. These are some formulae. These formulae are related to the lesson perimeter. Okay. Now, we are going to build up a formula for our relationship. Okay. First of all, you have to select the symbols. Okay. You have length, breadth and height. You can get the simple A as length, simple B as breadth, simple C as height and capital V as volume. This is the relationship volume of a cuboid equals to length times breadth times height. Now, you have to express this relationship in symbols. Let's express this one. Volume is represented by capital V, length is represented by simple A and breadth is represented by B and C is height. You can write this one as V equals A times B times C, or you can write this one as V equals A, B, C. You know that no need to write the multiplication symbols among the algebraic terms. Let's discuss a question. The length, breadth and height of a cuboid are 10 centimeters, 8 centimeters and 5 centimeters respectively. Find the volume of this cuboid. You already know that you have to represent the data in the diagram. Okay. What is the length? 10 centimeters and breadth is 8 centimeters and height is 5 centimeters. Now, you can write the formula. No need to write the relationship. Okay. Let's substitute the values. A is 10 centimeters and B is 8 centimeters and C is 5 centimeters. 10 times 8 is 80 and 80 times 5 is 400 cubic centimeters. So, the volume of this cuboid is 400 cubic centimeters. Okay, children. Now, we are going to build up the second formula for the volume of a cuboid. You can see in the screen, this is a rectangle. The length of the rectangle is A and breadth is B. This is a plane figure. You can find the area of this rectangle. Let's write the relationship. Area of the rectangle equals to length times breadth. Now, you can develop a formula for this relationship. I am going to use capital A for area. Capital A equals A times B. Or you can write this one as capital A equals to simple A times B. This is the area of this rectangle. Now, look at this rectangle. This is the rectangle. The length is A and breadth is B. Suppose this rectangle is a side of this cuboid. These two are coincides with each other. So, the length of this cuboid is also A and breadth is B. Now, we talk about the area of this rectangle. Area is equals to A times B. We discuss about that one. So, if capital A is the area of this side, then the area of this side of the cuboid is also capital A. Now, let's represent this data in a diagram. Okay, the length of the cuboid is A, the breadth of the cuboid is B, and height of the cuboid is C. Then you have ABC. Now you can find out the volume of this cuboid. V equals ABC. Then instead of A times B, you can use the term as A or the area of this side. ABC means the volume of A times B times C is the volume of this cuboid. Instead of A times B, you can use area of this side. It means A times C is the volume of this cuboid. Let's write this one. V equals A times C. This is the second formula for volume of a cuboid. Now, we are going to develop the relationship for this formula. V equals A times C means volume of a cuboid equals to area of the base times height. It doesn't matter, you can use the term base or side. Volume equals to area of the base time height. Okay, let's discuss few questions. Question number 1. The area of a base of a cuboid is 24 square centimeters. Its height is 8 centimeters. Find the volume of the cuboid. Okay, let's represent the data in a diagram. We have the area of the base and height of the cuboid. Now, we can use the second formula. Why is that? Because we have the area and height, A and C. So, you can write the second formula as V equals A times C. Let's substitute the values. A is 24 square centimeters and C is 8 centimeters. 24 times 8 is 192 cubic centimeters. So, volume of this cuboid is 192 cubic centimeters. Okay, this is the second question. I got this question from review exercise, page number 78. The area of the base of a cuboid of volume 70 cubic centimeter is 35 square centimeters. Find its height. Let's represent the data in the diagram. You have the value of volume and the area of the side. Now, tell me what is the suitable formula? Yes, we have area and volume. What is the suitable one? Yes, the second formula, A times C. Let's substitute the values. V is 70 and area is 35. 70 equals to 35 times C. You have to find out the value of C. Finding the value of C means you have to remove this 35. this 35 is connected with C by a multiplication symbol. So, how do you remove this 35? Yes, you know, you have to use opposite mathematical operations to remove this 35. You have to divide both sides by 35. Then you can get the answer as 2. Then the height of this cuboid is 2 centimeters. Okay, children. Now, let's talk about the volume of a cube. We talk about lot of things related to volume of a cuboid. We develop a relationship, we develop a formula. Now we are going to talk about the volume of a cube. Cube is a type of a cuboid. So, we can use the same relationship to find out the volume of the cube. So, volume of a cube equals to length times breadth times height. But wait a minute, all the sides are equal in a cube. So, you can use simple A as the side length of this cube. So, V equals A times A times A. This is the expanded form. You can express this formula in index form also. What is that? V equals A to the power 3. So, this is the third formula in this lesson. What are the three formulas? Let's revise the knowledge. B equals A, B, C, B equals A, C. Now, this is the third one, B equals A to the power 3. Let's discuss a question. Find the volume of a cube of side length 6 centimeters. Now, what is the formula? B equals A to the power 3. Let's substitute the values. A is equals to 6. So, 6 to the power 3 means you have to multiply 6 in 3 times. 6 times 6 times 6 means the answer is 216 cubic centimeters. Now, this is the second question. Let's read this one. By melting a solid metal cube of side length 10 centimeters, 8 identical cubes were made without wastage of metal. Find the side length of a small cube. Okay. First of all, we have to represent the data in a diagram. This is the large cube. The side length is 10 centimeters. And also, they are going to make 8 identical cubes from this large cube. They are going to melt this large cube. Then you can build up 8 small cubes. 8 small identical cubes. Remember that one also. How do you describe this question? It means they have a big cube or large cube. They are going to melt this cube. It means they are going to divide this cube or volume of this cube into 8 identical parts. So, you know that first of all you have to find out the volume of the large cube. You can use the formula V equals A to the power 3. You can substitute the value as 10. 10 to the power 3 means you have to multiply 10 in 3 times. 10 times 10 times 10 is 1000 cubic centimeters. So, the volume of the large cube is 1000 cubic centimeters. Now, you have to divide this volume into 8 equal parts. Then, you can get the volume of a small cube. 1000, if you divide 1000 by 8, you can get the answer as 125. It means the volume of a small cube is 125. Now, tell me, how do you find out the side length of this cube? Small cube, you already know that if you multiply 5 in 3 times, you can get the value as 5. So, the side length of small cube is 5 centimeters. Okay, this question is from exercise 22.1, page number 81. Okay, now we discuss about the volume of a cube and a cuboid. Now we are going to move to third part of the lesson, capacity. What is the meaning of capacity? Capacity means the volume of liquid that is required to fill a container completely is capacity. Volume of liquid, it means you need to have a measuring unit to measure capacity. So, what are the measuring units? These are the measuring units of liquids. If you have large amounts to measure, you can use liters. We represent liters by this symbol. And if you have the small amounts to measure, you can use milliliters. Milliliters can be represented by this symbol. Okay children, now we are going to build up relationships among the units of volume and capacity. What are the measuring units that we used? Yes, cubic centimeters, cubic meters, milliliters and liters. We are going to build up few relationships. Okay, let's move to the first relationship between cubic centimeters and milliliters. Suppose we have a cube of side length 1 centimeter. Now tell me, what is the volume of this cube? Yes, volume of this cube is 1 cubic centimeter. The amount of liquid that we need to fill this cube completely is 1 milliliter. So, you can build up the relationship as 1 cubic centimeter equals to 1 milliliter. You can see a symbol as Cc. What is the meaning of Cc? This Cc means the first 2 letters of the words cubic centimeter. You can represent the cubic centimeter in this way also. So, if 1 cubic meter is equals to 1 cubic centimeter is equals to 1 milliliter, we can represent this relationship like this way. Now we are going to prove this relationship in another way. For that, here I am going to use a small cup. The water level of this cup is 8 milliliters. We discussed that the volume of this cube is 1 cubic centimeter. Now I am going to put this cube into this cup. You have to observe the new level of liquid. What can you see this? Yes, the new level is 9 milliliters. It means it increased by 1 milliliter. So, you can prove this relationship by using this activity. It means 1 cubic centimeter is equals to 1 milliliter. Okay children, this is the first relationship. Now I am going to discuss the second relationship between cubic centimeters and liters. I told you that 1 milliliter is equals to 1 cubic centimeter. Now tell me, what about 2 milliliters? Yes, 2 milliliters is equals to 2 cubic centimeters. Then what about 10 milliliters? Yes, 10 milliliters is also equals to 10 cubic centimeters. Then what about 100 milliliters? Yes, 100 milliliters is equals to 100 cubic centimeters. What about 1000 milliliters? Yes, 1000 milliliters is also equals to 1000 cubic centimeters. Now, if you have the numerical value as 1000 with the measuring unit milliliters, you already know that 1000 milliliters is equals to 1 liter. It means we can develop the relationship like this way. What is that? 1 liter is equals to 1000 cubic centimeters. Now I am going to prove this relationship also. This is a glass tank. The side length of this glass tank is 10 centimeters. Let's measure this one. The height is 10 centimeters and the length is 10 centimeters and depth is also 10 centimeters. Now I am going to fill this tank with a liquid. This is a bottle. I have 1 liter here. Now I am going to fill this tank by using this liquid. Look at this, children. Yes, we can prove the relationship as 1 liter is equals to 1000 cubic centimeters. 1000 cubic centimeters. Okay, this is the second relationship. Now we are going to talk about the third relationship. Cubic centimeters and cubic meters, between cubic centimeters and cubic meters. 1 cubic meter is equals to, we can expand this one as 1 meter times 1 meter times 1 meter. Now I am going to convert these meters into centimeters. 1 meter is equals to 100 centimeters. So, you can express this relationship like this way: 100 centimeters time 100 centimeters time 100 centimeters. Then you can get the value as 1 million cubic centimeters. So, this is the third relationship. 1 cubic meter is equals to 1 million cubic centimeters. So, this is the last one. Now, we are going to discuss few questions related to these relationships. This is the question number 1. I got this question from your textbook, page number 85. Find the capacity of the cuboid shaped box in the figure. This is the figure. These are the measurements: 20 centimeters, 10 centimeters and 30 centimeters. We can find out the volume by using this formula as B equals A times B times C. Let's substitute the values. The length is 10 centimeters, 30 centimeters and 20 centimeters. 10 times 30 is 300. 300 times 20 is 6000 cubic centimeters. Now children, I want to convert this measuring unit into liters. So how do I convert this one? You already know that, remember about the first relationship, 1 cubic centimeter is equals to 1 milliliter. Then you can write this volume as V equals 6000 cubic centimeters is equals to 6000 milliliters also. So, you already know that if you have the measuring unit in milliliters, by dividing 1000, you can convert this value into liters. Let's divide this value by 1000. Yes, the capacity is 6 liters. The capacity of this cuboid is 6 liters. Okay, let's move to the second question. Find the capacity of a cuboidal shaped container in liters with length, breadth and height equal to 4 meters, 2.5 meters and 0.1 meters respectively. Oh, we have decimal numbers here. Let's try to do this question. First of all, we are going to represent the data in the diagram. The height is 0.1 meters, the breadth is 2.5 meters and length is 4 meters. Now, how do we find the volume of this cuboid? Yes, you can use the formula V equals ABC. Let's substitute the values. 4 times 2.5 times 0.1. 4 times 2.5 is 10. 10 times 0.1 is 1 cubic meters. 1 cubic meters. Remember that you have to convert this value into liters. How do you convert this one? Yes, we can convert cubic meters into cubic centimeters. You already know that 1 cubic meters is equals to 1 million cubic centimeters. So, you can write the volume as V equals 1 million cubic centimeters. 1 cubic centimeter is equals to 1 milliliter. So, you can convert this value into milliliters also. Then, how do you convert this milliliters into liters? Yes, you already know that you can divide this value by 1000. If you divide 1 million by 1000, what is the answer? Yes, the volume is 1000 liters. Okay, let's discuss another question. This question is in page number 84 from exercise 22.2. The base area of a cuboidal shaped container is 800 cubic square centimeters. If 4.8 liters of water is poured into this container, find the height of the water level. Look carefully, children. We have two different measuring units. The area is given in square centimeters and the volume of water is given in liters. You have to find the height of the water level in centimeters. So, first of all, you have to convert these liters into cubic centimeters. 4.8 liters mean you can easily convert this value into milliliters. How do you convert this one? Yes, you can multiply this value by 1000. Then you can write the volume as 4800 milliliters. Then you can easily convert this value into cubic centimeter as 4800 cubic centimeters. Now we have the volume in cubic centimeters and also we have the area in square centimeters. Now tell me, what is the suitable formula for this question? Yes, the second formula, V equals A times C. Let's substitute the values. Volume is 4800 and area is 800 and we have the letter as C. Okay, you have to remove this 800, you have to divide both sides by 800. If you divide 4800 by 800, you can get the value as 6. So, the height of this cuboid is 6 centimeters. Okay, children. Now, we are going to discuss another question. The capacity of a water tank is 6000 liters. After filling the tank completely, 800 liters of water is used per day for 4 days and 1000 liters of water is used per day for 2 days. find the volume of water remaining after these days. Now we are going to represent this data in a diagram. It is easy to understand. This is about the first 4 days and this is remaining 2 days. Let's find the volume of the first 4 days. You have to multiply 800 by 4. Then you can get the answer as 3200 liters. Then let's calculate the remaining 2 days. You have to multiply 1200 by 2. The answer is 2400 liters. Now let's calculate the total amount, the total volume of water used. You have to add 3200 and 2400. The answer is 5600 liters. Now you have to find out the remaining part. How do you find that? Yes, you have to subtract 5600 by the capacity of the tank. Capacity is 6000. So the answer is, the remaining volume of water is 400 liters. Okay children, we talk about the volume and capacity. Now we are going to move to our fourth part of the lesson, estimating the capacity of a container. What is estimation? Estimation means an approximate calculation or judgment of the value. You have to do a small calculation for your judgment. That is estimation. Okay, let's discuss this one from an example. So, let's discuss about this one from a small example. There is a container filled with liquid. If the volume of the liquid is measured by a measuring beaker, you can see that the level is 200 milliliters. So, the volume of the liquid is 200 milliliters. Suppose that I want to get the capacity of the container. For that, we have to estimate the capacity. How do we estimate? You can observe that the height of the container is 4 times the height of the liquid. Is it 4 times or 5 times? Yes, it is clear that 4 times. It is 4 times the height of the liquid. So, what is the small calculation that we have to do? Yes, to get the capacity of that container, you have to multiply this 200 milliliters by 4. Then you can estimate the capacity of that container as 800 milliliters. Okay children, let's discuss another question. This is from exercise 22.3, page number 85. Let's read the question. The volume of water in the container in the figure is 150 milliliters. Estimate the capacity of this container. This is the container and the volume of water in the container is 150 milliliters. How do we estimate the value? Yes, you have to do a small calculation. It can be observed that the height of this container is 5 times of the height of the liquid. So, you have to multiply the volume of liquid by 5. If you multiply 150 by 5, you can get the capacity of the container as 750 milliliters. It is easy, no? Okay, let's move to the next question. This question is from exercise 22.3, page number 85. Let's read the question. 100 lamps have been prepared for a function. 3 liters of oil were required to fill all these lamps completely. Estimate the capacity of a lamp. Oh, we have 100 lamps and also we have 3 liters of oil. You have to fill these 100 lamps completely and you have to estimate the capacity of a lamp. But you have the volume of oil in liters. So, first of all, you have to convert this value into milliliters. How do you convert liters into milliliters? Yes, you have to multiply this value by 1000. If you multiply this 3L by 1000, you can get the value as 3000 milliliters. So, you have to find out the capacity of the lamp. Tell me, how do we solve this one? Yes, remember that we have 100 lamps. So, you have to divide this value by 100. If you divide 3000 by 100, you can get the capacity as 30 milliliters. Okay children, we have come to the end of the lesson. We learned lot of things related to volume and capacity. We talk about the relationships among the measuring units of volume and capacity. What are they? Yes, 1 cubic centimeter is equals to 1 milliliter and 1 liter is equals to 1000 cubic centimeters, and also 1 cubic meter is equals to 1 million cubic centimeters. Then we estimate the capacities. Okay children, you have to do more exercises to practice these learning points. You have to do exercises in lesson number 22, page number 77. And remember that you can watch these lessons in channel NIE YouTube channel. Until next time I meet you once again with another interesting lesson. Stay safe. Goodbye.